first one, you should have put -2 in for y, 9 in for x. You square the -2, you get +4. Multiply those together, you get -20. Subtract those, you get -11. Anyone get anything different? The second one, if I do my math correctly, should have gotten -8 as a final answer. The exponents, you really could have done one and then the other, or both at the same time once you got to that step. Number 3, remember if you're combining like terms, you're doing whatever it says, so not the opposite. So 18 minus 7, 5 minus 9, to get that 11x minus 4. Four and 5, you need to actually solve for the variable. So 4 was 4, b equals 4. And 5, I got 12. Get anything different for those two? You have questions on any of these? So I'm going to try to do like one of these each week, just so you can refresh some maybe older algebra skills that maybe we haven't covered, maybe you have when you're solving, or courses that are within that, just so you don't lose those skills. So hold on to that answer sheet. Like it says score on them, but I'm not going to actually come with it. You could like score yourself, 1 out of 5, how many did you get correct, just to kind of see how you're doing with those skills. But it's not a necessary thing. I did give you guys the next course calendar. There's a lot of dates that are like, well, one, these are always tentative, they could always change. But there's a lot of things that depend on how much you get done within a class. So if you see like, it'll be due this date, if we finish this, those could change depending on what we get finished and what we don't. Within all of those papers, you should also have this set of notes. So the next few units are kind of broken up. It's like one big unit separated into like 3, all on linear functions. This first part is just going to be like stuff you should recognize, but it's okay if it's been a while. So like things like intercepts, slope, graphing, writing equations. And today we're going to start off with intercepts. So I'm going to go to this and pull this down so you guys can drop this down. I'm going to read this off because I didn't realize how small it was. So for X-Intercept, graphically, it's where the point crosses, touches, intersects the x-axis. Algebraically, it's where y is 0. So graphically, it's where on your x-axis, wherever it touches, crosses, intersects your x-axis. But algebraically, it's where y is 0. For your y-intercepts is basically the opposite. I know that's really small, that's why I'm saying it out loud. I'll rewrite it as well. Y-intercepts graphically is where it touches or crosses the y-axis. Algebraically, it's where x is 0. So, summary, Algebraically is where x or y is 0, depending on what you're looking for. Graphically is where it crosses or touches the x-axis. I'm going to just rewrite that because a lot of you are saying So if you're looking for an x-intercept, y has to be 0. If you're looking for a y-intercept, x has to be 0. X-intercept has to cross the x-axis. Y-intercept has to cross the y-axis. Okay? So y-intercept is just called a y-intercept. No other real name for it. But x-intercepts have different names. So one, they're called x-intercepts. You may also see them called solutions, roots, or zeros. All of those are interchangeable. So if I say find a 0, I'm still talking about x-intercepts. If I say find the solution, I'm talking about x-intercepts. Roots, same thing. All of those are x-intercepts. So if I say zeros, find the 0 or zeros, you're not finding the y-intercept. That's really all you need to know for that. Before I move on, does anyone still be writing that? So when you're given a graph and you're asked to find the intercepts, you just have to look and see where does it cross the x-axis, where does it cross the y-axis. For number 1, it might be easier if you look at your own paper than trying to explain it here. Where is our x-intercept? At positive 2. So we're going to put this as an ordered pair. 2, 0. Our x is 2, but our y is 0. Where is our y-intercept? Negative 3. Now our x is 0, but our y is negative 3. So from a graph, that's as easy as it gets. Questions on how we found that, how we write it, anything like that? For number 2, this crosses the x-axis twice, so you're going to have 2 x-intercepts and zeros. What are they?
Negative 4.
Negative 4 is one of them.
2.
And 2 is the other. Those notes are somewhere in so you can write it like how I just did, listing them out twice. If you have more than one, you can also list it, I guess, x equals, and then like curly brackets, from least to greatest, -4, 2. I think ran out of space there. But it says x equals, and then in curly brackets, -4, 2, and curly brackets. So you can write it either way when you have multiple. What is the y-intercept? I heard voices, but I didn't hear exactly what it said.
8.
8. We're going to do one more together, then I'll let you do the others. We're going to jump down to number 6. What are all the x-intercepts? Negative what?
5.
-5 is one of them. Okay.
0.
0 is one of them. And 3. So you can list each one out in as an ordered pair, -5, 0, 0, 0, 3, 0, or x equals least to greatest from -5, 0, 3. Do we have a y-intercept?
Yeah.
What is it?
0.
0. They can be the same thing. Sometimes it does happen. I'm going to give you 5 minutes to do the other 3. And then we'll come back and make sure we're all on the same page. Check your answers with mine. Should have had 2 x-intercepts for number 2. I'm sorry, we did that one. Number 3, you should have had 2 x and y-intercepts. I didn't list them out, but I can. So I'm just using the same colors I used here to not confuse you. If you wrote them out in curly brackets, they'd be the same thing, just 1x, 1y. Number 4 should have had 2 x-intercepts, -3 and 3. Five should have had 2 x-intercepts as well. 1 and 5. So you can have as many x-intercepts as it'll allow. You should really only have 1 y-intercept unless it's a circle or an oval. Yeah, this one. Or an ellipse. Anyway, you guys know that. Because then it wouldn't be a function. We're really only dealing with things that are functions. Questions on how to find intercepts on the graph? So now that we know it from a graph, now we're going to do it algebraically. Remember, algebraically, when we're looking for zeros or x-intercepts, y needs to be 0. When we're looking for y-intercepts, x needs to be 0. So for our x-intercept, if it's in fx form, remember that's just the same thing as y. It's just they rewrite it like that to mean a function. If that confuses you, change it to a y, it's the same thing. But to find your x-intercept, you're going to put 0 in for y to replace that value or that variable, and then solve for x. So I replace y, now I'm going to get x by itself by doing everything that we've been doing, get everything away from x. So add 8, divide by 4, x should equal 2. And then you can do the same thing for your y-intercept, except now it's going to be in reverse. We're looking for a y-intercept, we need to set x to be 0. What's nice about these is that if it's in this format and you set x to be 0, well, this is going to become 0. And then I can just solve this. If it's in that format, really you don't even need to solve for it. If it's in this format, whatever this term is, it's always going to be 0 because I always have to put 0 in for x. So really whatever this is going to be my y-intercept. Every single time, as long as it's in this format. If it's not in this format, that rule doesn't always apply.
Why did you change it to 4?
Change what?
It says 2x. I'm making it that.
Yeah, I was still working on number 1, not number 2. I just wrote this. I don't think I have what that's for. I'm going to come down to number 4 and do the same thing. So before that, do you have any other questions on how we got x or the y-intercept? So x-intercept again. I'm not going to change this to y like I did before, but you are more than welcome to do that every single time. I'm just going to skip to this next step and change this f of x to be 0. Get rid of it completely and just change it to be 0. Remember, f of x and y are the same thing, so I can do that. And then solve for x. So add 6 to both sides. And then either multiply by 3, divide by 2, or multiply by the flipped version of this fraction. So these will cancel, leaving 18 over 2, so 9. this is in that format that's similar, even though this is a fraction. That means I don't need to solve for my y-intercept. It's given to me. Question on either of those?
Why do you just get negative 6
So if I were to put 0 in for x, as x equals 2/3, this would become 0. So if you know that, then you don't need to solve for it. We'll do one more of these, and then I think that'll be it for today. Let's do number 6. So in this format, really solving for x is the most tedious. Friday, we'll go over some examples on that last page where it's not in this format and looks different, how you would solve those. So same thing, I need to get my x-intercept, set y equal to 0, solve for x. Get rid of 4 by subtracting. And either multiply both sides by 5 and then divide by 2, or multiply both sides by that flipped fraction. This would give me positive 20 over 2, so positive 10. What's my y-intercept? 4. There is a way to do it in the calculator, and I forgot to completely take this part out. Basically, if you're putting it in the calculator, it's you doing it from the graph, so it would be similar to you putting it in the calculator, looking at the graph. I don't have my computer graphing calculator to show you guys that. I can show you on Desmos, but you're not going to use that on the test or quiz. You also won't have questions like that on the test or quiz. So I'll show you a couple examples like that Friday. We'll go over a couple examples on that last page, and then you'll have the rest of class to practice. So for the remainder of class, if you wanted to continue those examples, you're more than welcome to. If you want to wait until Friday, you can do that as well. You do have one decimath. It's not due Friday, it's due Monday on intercepts, but if you wanted to get a head start on, you are more than welcome to. You also have 2 Khan Academies that are due Friday night. One is intercepts from a graph, the other is intercepts from an equation. Equation way too large, you might want to lean on, but the graph one, you